I'm just going to start with the question: what points are relevant for you if you want to choose a charging electronics? Because out there's a really big market of different distributors or manufacturers of EV charging hardware. It's a big risk for you as customer to make a wrong decision to choose the wrong EV charging hardware, because all of them are mostly doing the same, but they are also quite different in the options they are offering. So I just pointed out some points here, which actually are really important for you to know before you start of choosing an EV charging hardware. Starting with, do you want to do AC or DC charging on your application later? You want to do single or dual port charging. If you want to do dual port charging, you probably need to more or less copy the schematic a second time on your PCB. What charging power you need at the end? Do you want to do bidirectional charging? Do you have a display application later on? So you need to be sure that your charging electronic has at least one or maybe two display interfaces. You need some solution for payment for the customer later. You need also an interface for this on your baseboard. You want to do any other accessories on your charger later, like you need a SIM card for LTE or you need Wi-Fi or Bluetooth. These are all points you actually should need to know before you choose charging hardware. So you see, it's quite a long list, and the risk you have is if you make the wrong decision right at the beginning of your project, it will definitely cost you a lot of money. It delay your start of production and increase the risk of failure of your whole charging project. So we as PHYTEC knew this, and we said, we need something where we can take a little bit of this risk from our customers, and therefore we made a solution called the PHYTEC phyVERSO EVCS. The phyVERSO EVCS is really your all-in-one charging solution from PHYTEC. It is based around a Texas Instruments AM62 CPU, where we built our SOM around. It's customizable in, for example, RAM or eMMC or CPU version. If you say you don't need a quad-core CPU for your application, we can talk about what else you need. You need a dual-core, single-core, whatever. So we are flexible to this. The phyVERSO is a charging controller for AC and DC charging, and it can handle single or dual port charging. And we are flexible with it. So that means we are able to do a one-port AC, one-port DC charger. Or if you say you need a two-port DC charger, the phyVERSO will be your board. If you say you only need a one-port AC charger, even this, the phyVERSO will be your board for this. It has a separate microcontroller on the board for the safety-relevant software parts. It has two power line communication chips for each charging port. It supports two displays via LVDS, and it comes with a pre-flashed PIONIX BaseCamp development license. It has all necessary communication ports you need for a charging station, for example, RS485, USB, Ethernet, CAN. It's all available on the phyVERSO, and we're offering 6x fan support. We're also offering some extension, for example, Wi-Fi, Bluetooth, or LTE. And just to show you the advantages you have with the phyVERSO, you can develop with this in all different settings you need for EV charging. Like I said, you can do a one-port AC charger, you can do a one-port AC, one-port DC charger, whatever your later application is, you can do it with the phyVERSO. It is an industrial-ready product. When we develop a board at PHYTEC, we take a look on the parts we take to be sure that the developed board can be used in the industrial outside. So you can really put this board into your charger and it will work. You come to the PHYTEC software lifecycle management. So we will always update our BSPs and you will be always up to date with the software side, especially this is important for the security updates we offer for you. So you will always be up to date on the software side. We are offering, and that's a really important point from PHYTEC, we are offering customization or depopulation from boards. If you say you only want to build 50 charger, you probably will not use the whole PHYTEC phyVERSO as it is here on the picture, because, like I said, the board can do everything. you say you want to build a one-port DC charger, you probably don't use 40% of the parts on the boards in your series production later. So there we can talk about a customization, so building an own carrier board for you, where only the parts are populated you really need for your application. Or if you say, I'm building not so many chargers, we can talk about the depopulation of the phyVERSO, so that we always come to a cost-efficient end product for your series product. The next point from my side is how we will build the perfect charging station beside the charging electronic. The heart of every charging station is the charging electronic in combination with the software. But besides this electronic, a few more components are necessary to that the charging station will work. For example, high voltage DC contactors, which are special DC contactors which can handle up 1 kilovolt of DC voltage, which is necessary because we are charging up to 800 volt. You need some sort of isolation monitoring device, which is checking the isolation between DC plus, DC minus, and earth, which is quite a safety relevant part. You need, of course, a DC power supply, one or multiple power supplies depending on your final charging power. And you need some sort of DC meter for measuring and billing the customer later on what power he really charged his car. So you probably have to make two decisions. You need to make decisions about the upper mentioned part, so DC contactors, power supply, and so on, which are really depending on your charging applications. So power supply for 300 kilowatt will be a different one than for 20 kilowatt. And you need to make a decision for a charging electronic, which will be definitely the PHYTEC phyVERSO EVCS after this webinar, which is really independent for your charging application. The phyVERSO, you can use the phyVERSO as well for a 300 kilowatt DC charger as well as a 20 kilowatt AC charger. phyVERSO really doesn't care about especially about the power you want to charge later on. Because we as PHYTEC know how big such a project can be, and especially how big such an invest in such a project can be. We said we need something that you can test before you make this investment. We know you have to invest in engineering resources, in certification resources, in parts, in infrastructure, etc. So we have a high risk of failing if the time schedule gets delayed. And there we said we need something where you can make sure that the phyVERSO, in combination with the PIONIX BaseCamp software, is a solution for you as customer. And therefore, we created the EVCS-Cubes. We have two platforms there. We created the EVCS-Cube Basic, which is a single-phase 16 amp 3.6 kilowatt AC charger, and the EVCS-Cube POC, which is a three-phase 32 amp 20 kilowatt DC charger. Going a little bit deeper into these two platforms, we are calling the EVCS-Cube our development kit for you. So you can evaluate your application with these two platforms. The EVCS-Cube Basic is our AC charger. Like I said, it's a single phase 3.6 kilowatt AC charger, including a phyVERSO with a PIONIX BaseCamp software. It has everything you need to have a safety and proper charging when you receive it. It has a 16 amp circuit breaker in it, a residual current monitoring, a charge plug lock, an installation contactor, and so on. And it is ready to use for you. If you buy this, you can plug in your car and charge. We configured the software on the phyVERSO that it will work automatically. And on the other side, we have the EVCS-Cube POC, which is our DC charger. I said it's a three-phase 20 kilowatt DC charger, also including the phyVERSO and PIONIX BaseCamp. Again, it has everything you need for safe and proper usage, like a 32 amp circuit breaker, an RCD, DC contactors, like I already said the page before. It has a 40 kilowatt Huawei DC power supply in it. You can't use the 40 kilowatts because we are limited on the AC input side to 20 watt kilowatt, but we have a bigger power supply in it, and you will receive an LVDS display. And again, also the software here, we configured that it's ready to use when you receive this charger. You can plug in your car and charge. The DC charger, we work together with some other companies as the EVCS-Cube consortium. We as PHYTEC, we developed the phyVERSO, PIONIX, which are developed their software, the PIONIX BaseCamp. Alp is a company which is specialized to EV charging housing, which made these beautiful black and yellow housing for our DC charger. Huracan is a system integrator, which helped us on the schematic on the AC and DC side of the DC charger. And Freakly System, which have a huge knowledge on the BaseCamp side, especially on the BaseCamp driver support side. We also have 3 hardware partners we work together during the development, which is Huawei for the DC power supply, Actron for the display, and Isabellhütte for the DC meter. So this collaboration just should show you what we are PHYTEC are offering to you. We are offering these development kits, especially the DC charger, but we don't say if you buy the phyVERSO or the DC charger from us, we don't say do whatever you do whatever you want. We just sell you the hardware. We want to offer you more. If you say you have difficulties in the system integration, we can offer you Huracan, for example, which is one of our partners. They can help you with this. If you say you need somebody who's building EV charging housings, we can give you something on the hand there. So that's really what we were looking for, that we have a whole package for you that you can develop your charger faster. And yeah, what are your next steps? And why you should choose PHYTEC. PHYTEC has now 40 years of experience in electronics design. Our development and the production of our lead charging products are all made in Germany. We are offering a long-term availability. That means as long as we can purchase the parts, we will build our SOM and our carrier boards for you. We will find a solution for your product, but as long as TI is not discontinuing the CPU, we will probably build your board together. Our software lifecycle management, which I already told that you will always get the newest BSPs and software updates. And the most important point, we can customize the phyVERSO for your application, or we can also build a full custom design baseboard around our SOM, for example, for your application. This is really what we are good in it. We can design everything you need for your application on the baseboard so that you have the most cost-efficient end product for your series product.
If you look at EV charging over the last 15 years, there's way too many charging stations failing. It's been all over the news. We see a lot of LinkedIn posts. Take this post from Casper, the CEO of Monta. They're measuring the performance of all their chargers that they see. The failure rate of charging stations is way too high. There's a lot of different reasons behind it. One is pure software quality. We've seen the last year a lot of stranded assets. There's more and more companies in the US, but also in Europe, that either go bankrupt or stop doing EV charging business, and then you have charging stations that just end up not being supported anymore. Maintenance. It's sometimes hard to identify issues in the field. If there's a problem, it's not so easy to fix remotely. Someone needs to go into the field and do a repair. They need to have all the knowledge to do that. But one of the biggest problems that we see also is interoperability. Now, if you imagine that here in the middle is all the different charging station software stacks or charging station software out there. So a lot of variants on charging station and software. There's more and more EVs. When I started in this industry, there's a new EV coming out next month. That was news, or even 3 months away, the Tesla Model 3 coming out. Now there's a new EV coming out next week. And that's quickly now becoming, there's a new EV coming out tomorrow, which means if you're a charging manufacturer, you can't keep up with all the new vehicles, but all the vehicle manufacturers can't also test all the different charging stations. There's just too many variables to test. Now combine that with all the different cloud systems that we have for CPMSs and apps. This thing just becomes untestable. So interoperability is a big problem in the industry. Now combine that with all the different protocols. There is a lot of protocols that need to be implemented, and those protocols keep on evolving. Where 5 years ago everybody was still on OSP 1.6, for example, now that's moving to OSP 2.1, but the standard is already on 2.1. In January this year, OSP 2.1 was already released. So the industry needs to keep up. That's development effort. Everybody needs to basically reinvent the wheel. Everybody's doing the same thing over and over again. In the end, it's just the same software. It's not a something that's unique for a charger manufacturer. It's just commodity code. What if we would all do the same thing? So envision we make one open source project and all the chargers run on the same software. That means there's a community of companies working on one software stack. They implement the latest versions of a protocol, and everybody using that software stack then has that latest implementation. That is what Everest is. It's a software stack for charging stations that contain all the protocols, all the state machines to build a charging station. That means now things become testable again. EV manufacturers can test against Everest, knowing for sure that their vehicles will work with the open source software stack. If you're building a backend, you can easily test with Everest to make sure that your backend works correctly with Everest-based chargers. It's a lot simpler. It's a Linux Foundation Energy project, so you also know for sure that this is governed by a big organization. Linux Foundation is one of the biggest open source organizations. So it's not really a company that puts something on GitHub. This is supported by the biggest open source organization in the world, the Linux Foundation. So what is Everest? As I said, it's an open source charging station firmware stack. It contains all the protocols that you would ever need in a charging station. So it does OSPP, it does 15.8 for AC and DC, it does DIN-spec for older style DC charging, it does 61851 for AC in Europe, but also the US J1772, which is the small variant on that, and many, many more. Every time we're adding new protocols. It's written in C++. It also supports Rust nowadays. It comes with a lot of drivers for all kinds of common charging station hardware components. Nick already mentioned Isabella Hutte, for example. Isabella Hutte provided a open source driver for their DC meters. So if you want to use the open source version, that is already available there. And if you look at the software stack, it runs on Linux. So Everest needs Linux to run. That is all open source. Then you have Everest running in application space. And on top of that, a charger manufacturer can really develop their proprietary features, their unique selling points. So you don't longer need to worry about, do I have the correct version of OSPP implemented? Or there's a new version, I need to update that, I need to maintain it. By taking Everest, you get all of that from the open source project and have that support. If you, again, look at OSPP, Everest since last week now has already support for OSPP 2.1. That's probably the first actively used 2.1 implementation out there, and anybody that is doing anything with OSPP 2.1 can look at the open source project to even test OSPP 2.1. We're the most active community within the Linux Foundation Energy. We are growing quickly. We have a lot of contributors from all around the world. The majority is in Europe, but we have people from the US actively contributing. We have people from Asia actively contributing. There's continuous contributions to the project. If you open the GitHub, the last commit is typically not more than 10 minutes old. So it's a really active project. More than 50 different organizations have already contributed to it. So we're an active, big community and still growing. If you're interested, search for Everest. You will find us on GitHub and on the Linux Foundation Energy page. This is all the companies within the Everest ecosystem. They either contributed or they have drivers that are part of Everest. They're working with it. They're using it. A lot of different organizations here. These are charging station manufacturers, but also OEMs. We have standardization bodies that are active within the community. We have governments. We have more and more universities doing research. We have somebody doing a master thesis in Finland. We have people from Germany doing security audits as their master thesis. There's somebody in Canada doing a master thesis on Everest. So we see a lot more interest also from universities. The Joint Office of Energy and Transport in the US is an active contributor to Everest and promoting this in the US to grow the EV charging industry in the US. A lot of CPOs are using it to test their implementation against Everest to make sure that it complies and it works correctly with Everest. That's the open source part of it. Now, we as PIONIX have a more commercial version of Everest, which comes with additional services, and that is called BaseCamp. Nick already mentioned it a couple of times. This is based on the stable releases of Everest. It provides additional stabilized APIs. So if you want to integrate with Everest, you're always on the bleeding edge. And we know that if you want to build a driver with Everest, it's a very modular platform. You need to know quite a lot to build a driver that will keep on working over the years, because things change quickly within an open source platform like Everest. By providing more stable APIs, you can build your integration with BaseCamp, and we will make sure that these things are versioned and are better maintained and also more stable on the long run. So if you would switch to a later version of Everest in 2 years, you probably won't need to do any updates to your software, where if you would be on pure Everest, that might be the case. We keep BaseCamp versions longer compatible. So if you want to fall back to an older version, that's always possible. Everest doesn't really have maintained versions at the moment. You only get the latest version. They do sometimes there's an update on the latest stable release, but that's only 3 months old. Anything older isn't maintained by the Everest community. Any security related issue is automatically merged in. You can get SLAs from PIONIX that we will do security fixes or bug fixes for you quickly. And we do a lot more testing. We do a lot of testing with BaseCamp compared to Everest. We also don't release that quickly as Everest, because we take more and more time to release something, but this is then also way more stable and way more production ready. We can also, and all these updates, of course, can go over the air to the devices to update them. So what do we as PIONIX provide compared to our competitors that do commercial versions of charging station software stacks? If you look at the normal software stack, there's a lot of black box. You get binary code, or you get even source code that you can't change. And that's all a black box. You can't really change anything. Now, if you would go for BaseCamp for your charging stations, that means you have Everest. That's all open source. You get BaseCamp. That's all open source for our customers. And on top of that, you only need to develop your own proprietary unique selling points. That is typically a smaller layer than if we compare it to what our competitors are doing. And you have full control. There's no vendor lock-in. It's open source. So if you, for some reason, wouldn't be happy with PIONIX anymore, you can try to get support from somebody else within the community, or you can maintain it yourself. You have the rapid progress of what the open source community is doing. The development within Everest is happening really fast. As I said, we have already LSP 2.1 available. We just started for roughly 3 years ago with the project. We were behind on the market. We had to do OSP 1.6 and 2.0.1 to keep up with the market. Nowadays, we're ahead of the market, and we will probably stay ahead of the market from now on. We're a very secure and stable and tested platform. Everest is rolled out to more and more chargers in the field at the moment. We have a lot of customers under NDA. We have a lot of customers also public that are using Everest and are using BaseCamp. We have more and more security reviewers looking at Everest. There's a review going to happen this year that is sponsored by LF Energy. There's an official security audit going to happen there. On the one hand, of course, we don't hope that they find something, but on the other hand, it's really good that the security audit happens. If we find something, we can fix it before it causes issues in the field. So, yeah, big advantage of using BaseCamp compared to something closed source. Now, if you look at BaseCamp, is what do we provide? So the core is Everest. It contains all the communication protocols. It contains all the business logic, and it contains the set of open source drivers that is within Everest. If you go for BaseCamp, one of the first things you get is a set of tools that help you with integration and testing. You have really good documentation on validating your hardware before you roll this out into the field, before you go to certification, that you can already early on check different parts of your hardware, of your new board, your drivers, your cabling to validate if this would be able to pass certification even well before the charger is even completely finished, by isolating certain functionality and testing certain limited functionality in the charging station. So that comes with documentation, with tools to be able to do that. There's additional training that we can provide as PIONIX. There's additional drivers. There are some drivers where our partners say we don't want to make them open source, but we do want to make them available to people that use Everest. Those are typically within BaseCamp, or there are some drivers that we as PIONIX put in a lot of time and effort to get them working, where we are allowed to share them with customers, but we're not allowed to share them as open source. I already talked about the stable APIs. BaseCamp also comes with its own update mechanism. Of course, you can rely on OSPP for the update mechanism, but we also support RAUC update, which is more stable, but it's also very granular, so you can update smaller parts without having to do a full firmware update. Saves a lot on data cost. All of BaseCamp is pre-certified for all the security and all the safety certifications, OSP certifications, 15118 certifications that we know that exist. We can't certify the end product because typically those certifications don't allow you to do that, but we make sure that BaseCamp has passed this on, for example, the cubes. If we take the cube for certification, then we can at least show BaseCamp is capable of being certified. We can't certify the end product. If you take BaseCamp, you also get basic cloud access. We are developing a maintenance cloud. So if you're charging manufacturers, you want to have data from your charging station. Typically, charge manufacturers don't have any visibility on their chargers. They ship these chargers to a CPO. The CPO connects them via OSPP to their backend. That means the manufacturer doesn't see anything. Now, the big DC charger manufacturers in the world, they have a maintenance cloud that they use to provide SLAs to their end customers. If you, as a DC charger manufacturer, are responsible for the uptime of a charger, you need to have connectivity, you need to have visibility in that charger, and that's what these companies use a maintenance cloud for. And of course, you can develop this yourself, but we believe that if we as PIONIX develop our PIONIX cloud, we can provide this to a lot of different customers. We can do this way more cost effective than anybody could do it themselves, because we can provide it like a SaaS solution. And if you get BaseCamp, you already get basic access to it. If you want full PIONIX cloud, that's an additional license that you need to get. And on top of that, we have PIONIX Enterprise, and that comes with service level agreements that comes with long-term supported releases. Imagine you're making a charging station now, and within 4 years you go to a new product line. What do you do with your old product line? Do you keep these up to date with the latest Everest release, or do you want to keep them with an older release so you don't get any new protocols in, but you do want to keep them secure with the latest security fixes from Everest, for example? With the long-term stable releases, we make sure that those old BaseCamp releases will be patched for the latest security fixes without adding new functionality to them. If you want new functionality, you go to the latest BaseCamp release, you get all the latest functionality in there. BaseCamp basically supports you in your entire development cycle of your charging station. This starts with source code is available, documentation is available. So even in the definition phase, you can already work with, what do I need from it? What is it based on? It already have access to the source code to figure out what is it capable of doing. In your preliminary design, we really believe that the PHYTEC Cube, the AC or the DC one, depending on what you're going to build, are perfect solutions in this early phase on, okay, let's get this box, let's get it up and running. Does this do what we want to do? And then start designing from there, use it as a base, maybe adopt it, or maybe build something that's related to it, because it gets you up and running really fast. As soon as you're in the next phase, you go into design. That's where all the drivers come in. That's where you get things up and running with your own design. And then during implementation, the bring up modules that are part of the engineering tools really help you validate all your different hardware. So you have a meter in there, you want to check if the meter is working. There are steps on how to test this. You want to check low level communication, there are steps on how to test this. You want to check the PLC communication, there are steps on how to test the PLC communication. You're in testing phase. We make sure that BaseCamp is pre-certified, as I already told you. We make sure that security fixes are fixed quickly. And if you're in production, that's where the maintenance cloud comes in to give you visibility into your chargers. That's where also the SLA come in place. That's where the over-the-air updates come in place. That's where security fixes become important. So all of this helps you in all different phases of your charging station. If you end production for this charger, even before it's end of production, but you're not end of life with these chargers, that's where the LTS versions come into play for you. We all talked about Everest. This is the high-level communication of a charging station. So if you look at the software stack on a charging station, Everest runs on Linux. Next to this, and Nick already mentioned this, there's a microcontroller that is responsible for safety and also for low-level communication to the vehicle. If you look at IEC 61851 mode 3, it's a PWM signal talking to the vehicle. That's real time. Linux isn't really the best for real time, and a microcontroller can do that way better. So it takes on that role, but the main role that this microcontroller have is safety. If something goes wrong, this is the component that takes care that everything stays safe. Communication with Linux stops. It stops the charging process. It turns off everything. It switches off all the relays, and everything goes to a safe mode again. And this really helps also with certification later on. If you go for safety certification, having this split design helps a lot. We've done a lot of projects with customers already, and we've really seen that this, for us at the moment, is the best way to build a charging station. We, as PIONIX, provide the firmware for the phyVERSO EVCS, which is also then in the cubes. This has in-depth knowledge of how chargers work. A lot of timing issues within different vehicles are solved here. It's roughly 10K lines of code, and this is not open source. We do have an example. If you want to know what's in here, go to the PIONIX GitHub page. The firmware for our own dev kit is open there. You can look into that. You can use that. The firmware for the phyVERSO is based on that, so it's very similar, and it has a lot of the same functionality. If you look on the board itself, this is the phyVERSO EVCS. Linux and Everest is running on the PHYCore here, which is an add-on board, and the safety and low-level communication firmware is running in the microcontroller next to it, which takes care of both the charge ports on the board to make sure that everything is safe and the PWM signal is working.